what they were struggling with is just getting the data to even start, training a model or looking at figuring out what they needed.
All right, let me ask you this. How much of your time is actually spent solving problems, and how much is wasted just trying to find the right data? If you've ever felt like you're drowning in data formats, struggling to connect different sources, or just wondering why GIS feels so siloed, this episode is for you. Today I'm talking with Rob Fletcher, Chief Science Officer at Seer AI, a company tackling one of the biggest headaches in geospatial, data plumbing. Rob started his career at CERN. Yes, that CERN before making his way into geospatial and AI. And in this conversation, we get into some big ideas. Why finding the right data is harder than analyzing it, how the future of geospatial isn't about one company, but a coalition of tools working together, and how a simple dashboard they built for fun suddenly became mission critical for the US government. This episode is packed with insights, real-world examples, and even a few hot takes on the state of GIS today. So if you're ready to start solving problems and stop solving data, let's get into it. Today we're going to talk a lot about, kind of a little bit about your journey and some of the things that you've noticed during your career through geospatial and how that's ultimately formed into some of the products and tools you're building at Seer AI. But first, do you want to give like a quick intro about you and your background and kind of how we found each other here today?
Yeah, sure. So I'm Rob Fletcher. I'm the Chief Science Officer at Seer AI. I originally kind of started my career in physics. I did a PhD in particle physics. I worked at the Large Hadron Collider out at CERN in Geneva. So I did a lot of particle physics analysis. I worked on some what they call beyond standard model physics. A lot of what I did was just data analysis. We had very, very large data sets. We were kind of combing through them, looking for these very, very rare events. So it was a lot of statistics, a lot of writing code, that both kind of operated the machine and actually ran the statistical analysis and things like that. So I kind of got into machine learning and AI that way. Didn't really realize that's what it was that I was doing at the time. Didn't, I wasn't super familiar with that stuff, but ended up leaving academia, wanted to get into industry, found myself eventually at Esri, where I got hired as a data scientist. And so that was kind of the start of my geospatial career. I kind of went in thinking like, I've done stuff in, 3 dimensions, tracking particles through a detector. How hard can geospatial be? And turns out, there's a lot to learn still. It's quite a bit more than just, X and Y locations. So yeah, I kind of had a crash course there, did a lot of work there. And especially focusing on things like machine learning and AI for geospatial and temporal problems, things like that. Eventually met my co-founder at Seer AI, Daniel Wilson, and we met Jeremy Fan, who is now our CEO, and kind of hit it off. Had a pretty common vision for what we thought the future should look like, and so we decided to start Seer AI and go that way.
Awesome. So let's jump back. I mean, I admittedly know very little about particle collision. I know CERN, from a number of different places. I think probably the first time I came across it was the Da Vinci Code or something like that.
Yeah.
Or one of those books when I was in high school or something. But I mean, walk me through. I think when we talked, you said you were one of the first two data scientists hired at Esri. Kind of what was
Yeah.
that like, and what were some of the things? I mean, you kind of sounds like you're almost, if you're one of the first data scientists, you're starting from scratch building these things out. What was that like to kind of establish a data science or a spatial data science practice inside of the leading GIS company?
Yeah, it was interesting, and I think so. When I was applying for jobs, I had a couple of jobs from job offers from some big companies. Like I had a job offer from Google, and I actually decided to turn it down. I mean, for a lot of reasons. I came from like a really academic background, and just the thought of kind of going into something like that kind of environment was a little made me a little nervous. I didn't know if I was going to like it. And what I would have been working on was very, very specific. It was like, essentially it would have been, like, move this button from this corner of the window to this corner of the window, and measure how many more clicks it gets, and stuff like that, which I just wasn't interested in. When I found geospatial, it kind of presented, a huge number of challenges, which was really exciting to me. I mean, every single problem is so different that it's, yeah, just the problem space inside of geospatial. Like, I mean, it probably should be divided up more than it is into, kind of subspaces, but it tends to not be. But yeah, I mean, it was really interesting. And so coming into Esri, me and actually my co-founder Daniel Wilson, we were the first two data scientists hired at Esri. I was hired in the professional services group, so I was dealing more directly with customers. He was in the business development group, but he kind of worked in a little bit of like a team that was kind of trying to like figure out business needs and like trying to understand what businesses were going to need from AI and machine learning in the future. I was more on the side of like a client would come to us with a problem and I just had to figure out how to solve it. So it was a pretty exciting job for the most part. And I would say a lot of the challenges in starting something like that at a company are, first of all, is like the software foundation. Esri has a pretty good foundation of software for some things. There's a lot of, they have just a ton of software. And, especially things like their mapping software is pretty good. You can make nice maps, and things like that. They have a lot of server infrastructure that you can use, but they didn't have a whole lot of analysis software that was quite ready for the machine learning type stuff. They do have a lot of analysis software, but I found that a lot of it either didn't go far enough, wasn't adaptable enough. It was like a lot of the knobs were hidden. And so I found that a lot of what I had to do was start over from scratch and, build a lot of these things just completely from scratch in order to actually be able to achieve what I was trying to achieve in some, that was laid down by some client, some problem that they were trying to solve. So that was a major thing for us there was really building a lot of software from scratch that was just able to accommodate the kind of like very, very, wide variety of problem sets that we were getting there. And I would say another big challenge was actually on the business side. This is something I didn't anticipate coming in, but there's a certain level of training that even, things like project managers, account managers, like salespeople, they all need in sort of machine learning and AI that they didn't have at the time. And so it was really difficult without me being very, very involved with a lot of early client conversations to directing things towards what you can do and what, isn't really possible, because there wasn't a good sense of that, especially at the time early on in kind of what, when AI and machine learning was just barely starting to get popular. And so there was a lot of, sort of salespeople and account managers kind of agreeing to everything, not realizing that what they were talking about was, 25 years away from being able to be done. So I think that was a huge challenge. That was actually probably the bigger challenge for me personally.
Yeah, I think you hit on a lot of things that I've seen before just in my broad professional experience. When you say like, a lot of the things were that were hidden away in a way. And it's maybe not that they're hidden, but how they're run or maybe how they're executed isn't, it's, coming from a desktop GIS environment, myself, and that's where, how I learned and kind of, learn my skills. How to click those things and what you want to do. But maybe if you want to scale up or express that in a different way or understand how the wiring works a little bit, that can be a little bit tricky, so you have to kind of take those things out. And I think that's one of the core pieces of having a more wider modern geospatial data stack is you can pick and choose those pieces and pick the right thing for the job and go from there. And it's funny that you say, kind of talking about or training on like what are the edges of what you can do with ML or AI or deep learning or all those things and how do they all relate. I still feel like a lot of the time we kind of bundle that up in geo AI, and kind of say like, oh, this is all geo AI and that's everything. And it's, everything from, the simple clustering up to, some of the most advanced classification and detection models that I've seen. And I think one key piece within that is, of course, understanding what data you need to power those use cases. If you go all the way back to the beginning of like, I want to run a machine learning model. What data do I need? How does it relate? Is this going to help me? Is it not? And how do you build all those
Yeah.
pieces together? Which is, from what I understand, I think that's one of the big things that, you've identified as a core problem that Seer is looking to solve is, okay, how do we understand how data relates to each other?
Yeah, that's exactly right. And I would say one of our big struggles, pretty consistently early on, both me and my co-founder Daniel, was just getting either finding the data that we needed, or sometimes we would find it and just getting access to it, or getting it access to it in a format that we could actually use it. These were incredibly big challenges, especially early on. I would say in some sense, those have been eased a little bit, but in other senses, they've gotten even worse. Um, and so that's a big part of what we were trying to solve at Seer AI is that data access part. And this, it's funny, we didn't really, I wouldn't say we set out to solve that problem. We kind of started thinking like, oh, we're going to be, like an analytics shop. We're going to do AI, because that's the things that we were doing at the time, and the things that, we found a lot of clients were struggling with. But we found that, in a lot of cases, not all the cases, it wasn't really the analytics that they were struggling with. There were plenty of like really smart people out there that could do the analytics. What they were struggling with is just getting the data to even start, training a model or looking at figuring out what they needed. And that was kind of, we sort of settled into that and finding that like, oh man, most of the things that we're actually doing now are just kind of providing data to people. And so that's what we started to really focus on at Seer AI. And so yeah, what we're trying to build is a platform that enables you to not only find the data that you need, but access it in the way that you need it, so that you don't have to change the workflows that you're doing now. If you need to access raster data, as like X-ray or ZAR or something like that, something that's really cloud native, you can do that. If you need to access it on a map as a tile, you can do that in our platform. If you need to access it, as NumPy arrays, which kind of fits into ZAR and stuff like that too, you can do that. And so we try to provide data out to basically any way that somebody would need to use it. And we're always adding more ways as well. So not only kind of from lots of different formats, but providing it to lots of different formats and workflows, so that people can really focus on, especially people like analysts, the smart people in these companies that have good ideas. They can focus on executing their good ideas and not, fighting with data constantly.
Yeah. How do you help discoverability within that too? Because when I was building some of, like, I mean, I learned, probably not the best way for machine learning, but I learned from a lot of Medium articles and tutorials, and just trying to like figure, did some online courses. So, I know the rough edges, and I think, there was, I spent a lot of time trying to figure out how to do hyperparameter tuning. I don't know how much I gained from that type of stuff, but it's good to know. It's all of that. But when it all boiled down to it, and I think my biggest project was doing like, housing prediction on some data I found in Los Angeles. It all depended on good data, but what really stood out was understanding, spatially what it went into a decision around a housing price, and all the stuff that goes with that, with schools, with access to transportation, grocery store, you name all the things that might go into that. So how do you help, taking that out to a problem if someone's approaching something brand new, and understanding how
Yeah.
two data sets interrelate or don't interrelate? How do all those pieces kind of, how do you help someone understand that?
Yeah. So I think the first part of that is that our platform operates in an entirely decentralized way. So we reference data as opposed to store data. We can store the data, and we can do the typical ETL and stuff like that. But our preference is to point at external data wherever it lies. We like to leave it with the authoritative source if possible. Um, But then, I honestly can't remember how this originally came around, but we decided, we needed some way to like store all the references to the data sets. The first thought that, most people have is, oh, well, you stick it in a database. For whatever reason, I can't remember why, we stuck it in a graph database instead. And we built it into a knowledge graph. So, all of our kind of like record of all the data sets that we hold in our platform, we store in a knowledge graph. The idea being that we can now connect those data sets to each other, to concepts, to observables, to companies, to areas, to whatever it is. And it makes it so that somebody without a whole lot of knowledge of a particular vertical has many, many different access points to the knowledge that's stored in the graph. For example, one person who maybe is a geospatial expert might be entering a problem where they know that they need satellite data. They might be, entering with knowing that they need MODIS data or something like that, MODIS or Landsat, whatever it is. And so they might come into our platform and search MODIS or Landsat, and they'll find the reference to it right there. And you'll see a node in our graph that allows you to access that data, the entire catalog of MODIS or Landsat, wherever it is. But somebody might not know that they need that. Maybe you have somebody who is a, like one of the clients we've worked with is a hedge fund where they do prediction on, corn prices and things like that to try to understand, to bet on or against corn and, things like that. So they might come into our platform by searching for just corn. And so we'd have a node in the graph that was corn. And then because it's a graph database, you can expand those connections and sort of, traverse the graph in a way that you find the data that you need to answer a particular question or to find observables that tell you about something that you're interested in. So in this way, we kind of tried to make it not only just a database to store all of the data that we can reference, but also as a way of, having multiple entry points into where you can find the data, but then also how that data is related so that that there's multiple pieces of data that you can bring to a problem rather than just starting and ending with one.
Yeah, I mean, it's very interesting because when I look at different, like a different data source or a different kind of data, archive, let's call it that for now, but like Google Earth Engine, there's a ton of stuff
Mhm.
there. I don't
Yeah.
I don't know how it all interconnects. Like I can go find maybe something specific I'm looking for, but what else relates to that? What could I use that, can go along with that? And I think more importantly, you know, the question being here, of course, if you're an Earth Engine, you're using their systems and tools. What you guys provide is a way to use the tools, the data, the systems that you want. And I think more importantly, like you said, get it in the format you need and not force you to do all the transformations and things that go along with it. So it's not, the discovery, I think, adds a huge component, but also I think you call it the data plumbing, right? How do you
Yeah.
get it into the right places and things like that?
Yeah, that's exactly right. And that was a big frustration we had was that, if especially when we were at Esri, we were heavy users of Esri Living Atlas, and we still are actually. There's a lot of data there. It's in a particular format. It's going to be in feature services and image services, and they have their quirks, and you need to kind of learn your way around using those. But then you might also find that, oh, I need this other piece of data, but it lives in a completely different platform. It lives in Google Earth Engine, for example, or maybe it's just even Alaska Satellite Facility. It's just files in a bucket somewhere. The idea being that, yeah, how do you bring those together into a single model or into a single analytic? And a lot of times the answer was, well, you just got to download it, and that could be it can be difficult because sometimes the data that you need or the data that you might need for some dashboard where you have time sliders and you can drag all over the world, the data that you might need could exceed the capacity of your laptop or something. It can be incredibly difficult to do that. And so yeah, we tried to make a system where the data source didn't matter. So any of the nodes in our graph, represent a data source that you can access through standard APIs, no matter where they come from. It doesn't matter whether they're a Living Atlas data set, they're a GeoParquet data set, they're something on Google Earth Engine. It doesn't matter. You can access all of them in the exact same way. And we've done this a few times for some clients. One of the ones I can talk about is ExxonMobil, one of our clients. We were doing some pipeline monitoring stuff for them in Papua New Guinea, where it's a very highly seismically active area, and they needed a better way to monitor their pipeline. They had been trying to use SAR for years, because SAR can see through clouds, where I think it's 90% of the year it's cloud covered. So it's impossible to use imagery, optical imagery. But so they've been wanting to use SAR for a long time. The problem they run into is that there's a jungle there, and there's huge trees that move around, and so the SAR is incoherent. You just can't really use it. You don't get two passes of SAR that look the same. And so we were able to put together an analytic for them and help them with this, where we brought together, I think it's 14 different data sets, or maybe 12 different data sets, all from different places. Some from Google Earth Engine, some from USGS, some from Esri. We were able to bring them all together and feed them into a single AI model that does some predictive analytics to help them understand how soil moves around their pipeline and things like that. And so that's like really, I think, a good example of the kind of end goal we were after, is just really bringing all of these different data sets, no matter where they are, into the same workflow so that you can do something cool with them. It's what it's all about. We've found over the time that one data set usually doesn't cut it. It's, if you're actually doing something really challenging, you need multiple data sets in order to get enough information to actually solve real problems.
Yeah. Well, I think I have a note here from our talk earlier. It's start solving problems, stop solving data, which is that resonates quite a bit with me. I can say that. I've spent a lot of time moving data and things like that. And what it reminds me of, I always try to like picture a parallel to what the broader data space is doing. Because I think there's a lot of things that where they're maybe a few steps ahead of geospatial, but it almost feels like and correct me if I'm wrong, but if I'm saying I want to connect to an Earth Engine data set, and I can connect to 3 other data sets in different formats, I can now have one single kind of way to access those and bring those into a format that works for me in my workflows.
Yeah, that's exactly right. And I think the big key here, though, is that what we didn't want to do was, we did not want to set out and create a new standard. One of my old coworkers used to say something that I loved. He said, the great thing about standards is there's so many of them. And that's always really resonated with me and with my co-founders as well, in that, you can make a new standard and you just hope that people follow it, but probably not. You'll have some small percentage of people that follow it and some that don't. And so what we really set out to do is, instead of making a new standard, is try to make it so that lots of different standards could talk to each other, and make it so that rather than having to do things our way and learn the Seer AI way of doing things, we then we almost do 2 translations on data. We translate the data as it's coming into our platform, and then translate it back out into whatever way the user is requesting them. So if you're requesting this data from, like some sort of a web map, like that's using, let's say, OGC, standards, what you're going to receive is OGC standard data, no matter what source it's from. Same with, if you're using Python and you want to be working in pandas data, pandas and, just array formats, NumPy arrays, things like that, that's what you're going to receive back if that's how you're requesting it. And so we're not trying to force people to say, hey, we have this new standard that unifies everything. We're saying, no, we kind of have to meet the clients where they're at. Instead of them learning something new, we adapt to whatever workflow they have. We found that also within companies, the difference in workflows is huge. You'll have a GIS group that, maybe they're Esri users, and, so everything they do is in Esri format, but then you have a business group that maybe they do stuff in, Tableau, or, maybe you're lucky and they're doing stuff in Python. And those 2 groups just can't talk to each other. There's this huge wall in between them. And that wall is usually, that the business group has no idea how to interact with a feature server. And the GIS group, wants to interact entirely with Esri and can't deal with the sort of more, outside of GIS Python type things. We kind of want to, sort of, not even just like bore a hole through that wall. We want to knock that wall completely down and make it so that those 2 groups can now talk to each other. So it's it's a little bit of like, bridging those gaps and bridging these groups that normally would have a really, really hard time talking to each other because their tools just aren't really compatible. They don't have the time to learn each other's workflows. And so the GIS group being able to provide GIS data outside of their group is hugely powerful to these huge companies. The same with the other sense is that taking this business data and being able to provide it into the GIS group so that they can do more spatial analysis. That's really the goal, is to kind of knock down a lot of these barriers that you find, not only between an analyst and whatever data they're trying to access, but just knocking down barriers between groups in a corporation, in some larger organization in general.
Yeah. What it reminds me of, and maybe doesn't remind me of, but I've been looking for a solution like this in geospatial, which it sounds like, fortunately, you guys are tackling, is something like an Airbyte or a 5tran for geospatial data. And if you're not familiar with those tools, for the folks listening, Airbyte allows you to connect. I think they're up to like some 300 different data inputs and outputs, right? It's what you would call an ELT tool, extract, load, and transform, right? And it's not focused on elaborate data transformations. It can do some, of course, but imagine you're in a marketing sort of organization and you need to connect data from Google Analytics. Maybe you're running ads on some sort of platforms. You're collecting data on Salesforce and any other of the plethora of marketing tools that is covered on that platform. And you need to get it all into one place. Maybe it's one place for a data science team. Maybe it's one format for your business intelligence dashboards. Maybe it's just spreadsheets so someone can look at it there. That's kind of what that tool does. It says, I take these formats, which you would have to write a ton of code and a ton of heavy lift to get all that in, bring it into one standard way so that team A, B, and C can get access to it. And geospatial has never had an easy way to do that. Sure, GDAL can translate data, you can do these different things, but it's not consistent, it's not repeatable, it's not updated. If there's time changes, you have to go manually do that. Having a way to do that sort of translation and like the data plumbing, if you will, that is a big problem. So I'm like, that gets me excited to hear about these types of things.
Yeah, and I would say there's a couple things you hit on too that are things like you mentioned, once you copy data, once you ETL data, that data is immediately out of date. If as soon as you're bringing it out of the authoritative source, it is sort of no longer authoritative, or you are taking on the burden of becoming the authoritative source, internally for that data, which can be a huge burden. And so that's one of the reasons why we take a really decentralized approach to these things. Like I said, we can ETL data. We can point at data wherever it is, whether that's internal storage or external storage. We prefer to leave the data with whatever provider is the authoritative source, or wherever the analytic was run. Maybe the data is the output of an analytic. We would prefer to leave it with them. They're the ones that know how to access it, know how to update it, know how to do all this kind of stuff best. We just want to provide that into other people. And so we take a really very like cloud native first approach. We're following a lot of what's going on in like cloud native geospatial, which you are very familiar with. And so we're following a lot of what's going on there and trying to participate in stuff like that, because we want to really participate in that whole ecosystem. We kind of think that like the future of geospatial, I don't think is going to be solved by a single company. I mean, you had these giants like Esri in the past, but I just don't think that's going to happen again. I think it's going to be like a coalition of lots of companies that are really going to be the future of geospatial, and we really believe in that. We really believe in that future, and so we are trying to be this one piece of it. We're trying to be the data plumbing that gets everything, from where people need, from the authoritative sources to where it needs to go. But keeping it as cloud native and decentralized as possible so that you can still maintain these things like authoritative sources, where, you get data updates regularly and things like that. So in a lot of ways, we're a little bit like we kind of refer to it as like a CDN, but for geospatial data. A lot of people on the internet, well, I mean, really almost everyone in the world today, uses a CDN hundreds of times a day, and they, maybe people don't even know what a CDN or a content delivery network is, but they're still using it. And that's kind of where we feel like we sit, is that plumbing that kind of sits behind the scenes and provides everyone with what they need so that they can do their jobs and they can take advantage of, the analytic platforms or the mapping platforms that they're most comfortable with and that are going to be best for the job.
You essentially elaborated, and depending on when someone's listening or watching to this, it may be out already, but you just hit on the main point of a blog post I'm working on right now, which is I very much am in line with that vision that as a geospatial industry, there's no one ring to rule them all. And I think as the future will be, much as it is within the modern data stack, different components, tools, and organizations that are focusing on one specific part of the problem that will help accelerate the entirety of the workflow. And that's a big paradigm shift it's a big paradigm shift in data. And I think it'll be a big paradigm shift for geospatial. But as you said, I'm also of the belief that that is the right way to go. So that's a huge piece there that I think is really interesting. And I think you're focusing on a gap, right? There's obviously a clear gap there. And then, so now we have a pause. Is there anything else that you wanted to specifically point on? Otherwise, I was going to move into use cases, and then kind of, I think we had some notes on, for the use cases, local government, disaster response, stuff like that. We can move into that, and then kind of that getting the data to the masses. I think wrapping up to say, how can someone get started and start using, or where, who would this be applicable for? Does those sound like the next two chunks to get, or is there something else that you wanted to cover there?
No, I think that sounds great. I think, we've covered a lot. So,
okay, good. So let's jump into how, some different use cases, and I've been following you guys on LinkedIn and some of the different social channels, and what I've seen a lot of is some very timely response to, some different things, like, very localized but specific disaster response. I know some of the posts on flooding, I think it was in North Carolina, some responses to Los Angeles fires. Walk me through kind of what this might look like for a municipality, a county, or we can go down to that scale, but someone who wants to like leverage, Seer to get into those types of use cases, and how might they get, kind of going with something like that?
Yeah. We've been doing a lot of the disaster response stuff recently. I would say that's, for a lot of us in the company, that is where kind of our hearts lie. Is the work that we would want to be doing is any kind of work that helps people. I think that that's a lot of where geospatial can be most powerful, is really in helping people. There's just so much there that everyone can do, and so that's a big place where we're working towards, is really trying to build up these solutions for things like that. But yeah, so the stuff you were seeing, we did some responses to some of the hurricanes you saw recently in the Southeast, as well as some of the fires out here in California. A lot of what we were doing there was providing timely data to first responders. We weren't really doing anything, I would say, super sophisticated. There wasn't a whole lot of analytics or anything going on. A lot of it was just getting data from where it was getting dumped by, NOAA or whatever satellite company was producing the data. And we were bringing it all together into one dashboard, into one place where somebody could look at it, and where then analysts from companies, or not companies, but organizations like FEMA or Army Corps of Engineers, or whoever it is that is, a first responder or even a second responder out there, can get access to it. They can do the analytics they need. They can do the recovery that they need to do. So that's been a big focus of ours recently. And it can be a big challenge for these people, because they're not always geospatial experts. I would say that they're very good at looking at maps. That's a lot of what they do, is they look at maps. They understand the maps. They understand, really instinctually how to take that information and to use it in the real world to help people. What they don't tend to be good at is bringing all of that data together to be able to put it onto a map. And so that's what we were doing in a lot of these situations, is just getting all of the relevant data necessary and bringing it and putting it onto the map very, very rapidly. In a lot of these cases, we were even running some AI models on some of them too. And because we're able to get access to the data so quickly, we're able to run these models very quickly. And we were able to have some things like debris models that we were running on hurricane imagery that we were able to have to the first responders within an hour of the imagery being available, for the entire state of Florida, things like that. And so, that's kind of like a big focus for us in that realm, is just let's get this to the people that need it as fast as possible in a useful format so that they can make decisions. Is really what we're trying to do there.
So in those situations, I mean, there's an element of speed, being able to get the updated data, which you kind of said, a geospatial CDN that is consistent, synced, up to date. And then also, being able to get that into potentially multiple places or teams, right? What are some of the teams that are kind of using this? Because across and I've talked to, it reminds me of, I think, AWS reInvent, when you're talking to, a number of different folks that use geospatial data, from the scientists that need it in Python, they're kind of studying and analyzing these things, to people that are on the ground and may not have cell service that need something pushed out right away. There's a wide range of those kind of end users, and from what we've been talking about, it sounds like that ability to distribute in multiple formats, multiple ways, could be a big advantage in these kinds of cases.
Yeah. So when we were doing some of these, it's kind of funny. We didn't realize how these were being used at first. A lot of this was, we kind of threw some of this together, almost as a marketing piece. We were just sort of like, oh yeah, were some hurricanes down here that we heard about, and so we were like, oh, let's just throw together some dashboard. Really as an afterthought at first. We kind of threw it together. We released it, I think, on LinkedIn, and just said, hey, go check out this dashboard if you want to. And kind of didn't give it another thought for about a day or so. We ended up getting an email from, I can't remember exactly who it was. It was somebody pretty high up in Southcom, who was, the Southern Command, who was responding to a lot of this disaster. We got an email that said, like, hey, are you guys going to update this dashboard? What's going on here? And we sort of didn't even realize that anyone was really using it. We just kind of forgot about it. We were like, oh yeah, okay, yes, sure. And so we started updating it and things like that. But yeah, a lot of it is providing this data to, not only the decision makers, the people kind of higher up that do just want a map, right? They just need to be able to see it. They need to, point at a map and say, okay, this is a problem spot. This is a problem spot. We need to get somebody to look here. But then also providing it to the more kind of analyst people who are maybe going a step further and saying, things like, where will there be problems, or where are there problems that we can't see on a map, but the data will tell us. We had some internal people like doing some analysis on stuff, and we were trying to find things like areas that were cut off. So like when the hurricanes happen and roads get flooded or debris covered, are there areas that are completely cut off from first responders or emergency services because of that? And then, trying to flag those early on. I don't think this was something that we released, but this is something that we kind of looked at a little bit. And, so it's that kind of analytics that we want to enable, in addition to the people that just need a map. They just need to look on a map and make some decisions quickly on things like that. But then there's also, a much longer tail to that. A lot of people, they're still doing recovery from these hurricanes even now. There's still people that, lost their homes or their homes were damaged, and they're still trying to, rebuild or even get checks from the insurance company to cover some of these things. And so, there's this very, very long tail of information that needs to still get out to these people, and it needs to be continuously updated. There's analysts that are going to be accessing it for months, trying to understand the scope of the damage, the scope of the recovery needed. And so it's those kind of people as well. It's not just the early on, but it's providing up-to-date information to all the people that need it for the months and months and months that come with recovery afterwards.
Yeah, there's a big push at the beginning, obviously, when you're in a very real-time response situation, but the continued need for understanding what happened is one piece, and then that's going to go on for a long time. And a lot of these areas are still unfortunately struggling, and we'll need the better data will help them hopefully get resolution sooner. So that's
Yep.
that's one key component. The second part is, of course, how can I use that data to maybe do something different in the future, or see,
Yeah.
there's two pieces. What could I do different in the future, or can I anticipate risk coming up? Right. And that's
Yeah.
one part I think we saw with the LA fires was, it was so fast, and fires are a tricky one because it's hard to predict where a fire is going to start. It's almost impossible unless you're seeding multiple locations and trying to figure this out. I did an episode about that earlier, but it's even having an ability to just say, like you said, what's my risk now in the data, and getting a very clear view of that from a real-time data set. And there's good data out there. We know that.
Yeah.
And then even being able to, just start to approach models like that to say, I can, be able to maybe seed or predict or say, hey, if something starts here, I can start to take action on that now to maybe get ahead of that, knowing that
Yeah.
there's a massive risk. So, having that very up-to-date view of the world is important.
Yeah. One of the things that uh, we don't advertise a whole lot, but it's something that is available in our platform is we have something that we call a remote provider, which is a way of kind of encoding your own way of accessing data into our platform. So, when I talked about before, we can access data and then also provide it out to whoever. We kind of split that up into what we call providers and servicers. So the provider is what knows how to talk to the data. The servicer is what knows how to talk to the client, whoever's asking for it. We have an SDK that allows you to write your own provider in Python, or really any language. It uses gRPC and stuff like that, so you could really implement it in any language. But we have an SDK for Python. One of the things that we were doing, kind of as a little bit of a demo, was actually just writing simulation in that Python, so that the simulation could be provided out as any other data source could be as well. And so we were doing simulated lightning strikes, kind of with the thought of fire starting and things like that. We've talked with a couple of these companies that do fire modeling. We're not experts on fire modeling, but what we could do was show them that, hey, we can simulate lightning strikes, simulate data, provide that out in the exact same way that normal data would be provided, to whatever system you're using in order to actually do that analysis and do those studies, making it so that when a real event comes along and you need to flip that source over to a real data feed, it's a simple matter of changing, literally just pointing at a new data source. So that's another thing that we can do, is we can actually, you can write your own simulation that can then be provided as if it were any other geospatial data source, so that you can do those kinds of studies and things like that, which that's something we're pretty excited about. We don't advertise it a ton, but it is something that you could do. It's a little bit more of an advanced use case.
No, I go back to Airbyte, where you can write your own connector and kind of build those things. I was like, maybe I'd try that out if I have some extra time, but I'm like, well, this seems like the right place to do that because it's already in geospatial, so it can connect to
Yeah.
everything else. Very cool. So if I'm looking to, how would I get started with your platform? Like, what are some of the prerequisites? What would I need to know, and how would I kind of start to explore it a little bit?
Yeah. So, the main thing is we have a SaaS platform. So you would just need an account for that. And you can write us contact@seer.ai. If you want to get started, we can provide some trial accounts and things like that to our SaaS platform. We curate a lot of data on our SaaS platform. So we have what we call a global graph, which is a big graph of all the data that we sort of pre-curate in the platform. But we also enable you to bring whatever data set you want in our web front end with a couple of clicks. You can just sort of point at the data, give us some information about how to access it, and you're good to go. You've now got a new node in the graph that you can connect however you want. We also have a full Python API. In fact, our Python API is the kind of most complete right now. You can do anything in our platform in the Python API, which you download like normal pip install, that kind of stuff. You still just need an account to do that. And then our web front end is very quickly catching up to our Python API for the kinds of people that maybe aren't necessarily as comfortable with Python and are more used to kind of like a desktop GIS type experience. We can provide that as well. But yeah, we're We also have, an enterprise version where we can install the platform, behind a firewall if needed. That's going to be mainly for more large organizations, governments, things like that. But a really quick, easy way to get started is just to send us an email at contact@seer.ai, and we can set you up with an account. You can try some stuff out, add some of your own data sets, and see how it goes.
Awesome. Well, thank you again. I definitely have some ideas, so I'm very curious to see how this could play out and connect to solve some of these like the old data connectivity problems that are a day-to-day thing. So
Yeah,
yeah,
let us
thank you.
know. Love to
Yeah,
help out with that.
for sure. Well, yeah. Well, thank you again for joining. It's been cool to kind of hear your journey and how things have played out. Kind of going and seeing these problems and then jumping in and solving it. And I think adding a very key component to, kind of the geospatial data stack and kind of where the industry is going. So, Rob, thanks again. Appreciate it. And yeah, we'll talk soon.
Thank you very much for having me, Matt. Good to be here.